This is part 1 of the Youth Space Organization series on star formation. So I really love using numbers as comparisons, especially of unrelated topics. So we're going to start off with a question, which is how many videos are on YouTube that are publicly visible? I'll give you 3 Mississippis. If you answered 10 billion as of 2023, you are correct. And the point of asking this is that we all know that YouTube is giant and has a lot of videos. Well, astronomers estimate there's up to a septillion stars in the universe. That's 10 to the 24th power. To put that into more digestible terms, if one star is equal to one video on YouTube, it would take 100 trillion times the 10 billion videos already on YouTube in 2023 for there to be enough videos as stars. So this is a famous image from NASA. We've all seen it, but what is it? Well, NASA describes it as a stellar nursery, and we notice that there's a lot of sparkles, which are just stars, and the back is your regular dark background of space. But what's interesting is what appears to be mountains or wave-like brownish orange gas or dust. So molecular clouds are large clouds of gas and dust, and when molecular clouds are cold, it causes the clouds to clump together. So now you have a lot of mass in a small space. In other words, there's high-density pockets. These clumps collect more matter through collisions and eventually reach a critical mass. That just means they become big enough for the pre-star to collapse inward because of gravity. And our two objects of attraction are two gas particles, one at the center of the ball and one at the edge of the ball representing the clumped up molecular clouds. The force of gravity increases because we go from these gas particles being farther apart before they were clumped together to a smaller radius because they are not together in a ball. To a smaller radius because they are together in a ball. There's particles colliding more and more now, so another force comes into play to really make the end product a star, which is friction. Friction is just a force that resists motion as the particles collide. And as what happens with friction, this results in thermal energy. So why don't these clumps become an ultra-dense ball if gravity is yanking the clumps inward? As we mentioned, because of friction, there's thermal energy. And it's the fact that it's really hot and there are these really fast collisions happening that oppose the contraction of gravity. By that, I mean specifically the collisions are opposing the contraction of gravity. And this heat leads to the development of a protostar. So is our sun a protostar? Pause the video and answer. It's not, because nuclear fusion does not take place in protostars. And tune in next time for the life of a protostar. These slides are available in the caption. Thank you.